Okay. All right, so this chapter, chapter 9, is on exponential functions, exponential and logarithmic functions, which I'll call logs because logarithmic is a little bit of a mouthful. So here's a definition. Let's first define what these are. And they're very much related to each other. In fact, we call these inverse functions of each other, which you will spend more time getting to know about in pre-calc. Okay, so an exponential function is written as f of x is equal to a to the x, where a is the base and a cannot equal 1, and x is any real number. Okay. So what looks different here compared to the other function we've dealt with? What is special about this exponential? Anybody know? Where's my variable at?
In the exponent?
In the exponent, okay? So the variable is in the exponent. That's what makes it an exponential function. Now, the base is typically a number. You can have bases be variables also, but those are kind of special and we really don't deal with those until you get to calculus, okay? So you can have like x to the power of x, believe it or not, but we're not going to touch that, all right? So generally speaking, the number is, or the a is the base, and it's generally a number, okay? So let's look at, and we have seen this before, but we've never done like lots with it in terms of operations or graphing, okay? So let's look and see, what do these look like? So let's graph. F of x is equal to 2 to the power of x. Okay. X and f of x. All right. So what I'm going to do is I'm just going to pick a bunch of numbers to plug in. So 0, 1, 2, 3, 4, and then -1, -2, -3, -4. Now, if you've had a good class before, either in high school, you had a good teacher, or you were just a really good math student, you might remember the shape of these graphs, but we're going to take our time here and graph out some points. All right. So if I plug in 0, f of 0 is 2 to the power of 0, which is just 1. So that's my first point, 0, 1. And then f of 1, all we do is we plug it in where we see the variable. So 2 to the power of 1 is just 2. Okay. F of 2 is 2 to the power of 2, which is 4. So it's 2, 4. F of 3 is 2 to the power of 3, which is 8. So 3, 8. F of 4. Okay, what about 2 to the 4th? What's that going to be?
16.
16. I'm kind of just flying through them here. But okay. All right, so that's pretty straightforward. We're just taking everything to a power. Now let's look at what happens when we do negatives. So f of -1 means 2 to the power of -1, which is really what?
1/2.
1/2. Okay, so we're going to look at the reciprocal of that. So that's the point -1, 1/2. All right, what about f of -2?
1/4.
Yeah, it's going to be 1/2 squared, which is 1/4. All right, f of -3?
1/8.
1/8. Now, are you calculating that in your head, Christian, or are you just, how are you getting that?
Yeah, kind of. I kind of went ahead and did it.
Okay, so
I mean,
you actually think 1/2 cubed, which is 1/8, that's your process?
Yeah.
Oh, okay. All right, good. Oh, whoops, I wrote the wrong thing down here. Oh, I really wrote the wrong thing down here. What happened? My mind must have wandered. -2, 1/4. This is 1/8. All right, what about f of -4?
16.
1/2 to the 4th, which is 1/16. Notice though that, I mean, I was wondering if you guys were just noticing that when you put in the opposite, it's the reciprocal. Did anybody see that? Like, oh,
Yeah.
that's just going to be 1/16. So for example, what would f of -5 be?
32. 1/32.
1/32. Yep. So anyways, these are powers. We see they're just powers. All right, let's look at this graph. Check out the graph. Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's y, here's x. All right, so 0, 1, right there. 1, 2, over 1, up 2. 3, 8, over 3 and up 2, 3, 4, 5, 6, 7, 8. And then 4, 16. Holy cow, that's like way up here. I'm just going to guess. Actually, I think it's probably higher. It's probably like 4. I don't know. It's higher than that, but I'm out of room. Okay. Now, going the opposite way, -1 is 1/2. That's halfway. -2 is 1/4. Oh. -3 is 1/8. I can't get any closer to that line without being on it. Okay. So I'm just going to kind of like, I know it's going to skate really close to that, come up through 0, 1, and then get really big, really fast. Actually, it's going to be more like that. Okay. So this is the graph f of x equals 2 to the power of x. Okay. So here's a couple of things to notice. What's happening on the positive side?
Getting bigger.
Yeah. When x is going to infinity, I'm going to write it like that, getting bigger. The outputs blow up. Meaning they get huge. You guys see that? So for example, if I put 10 in here, that's going to be 2 to the 10th power. That's huge. I don't even know what that is off the top of my head. I'd have to definitely use a calculator, but it's going to be something probably in the 100,000s. Okay. So that's only going out to x equals 10. We have like all these numbers. We have like 1 million hanging out here. Okay. So imagine 2 to the million. All right. So exponentials, the bigger the input gets, the outputs get huge when your base is a whole number like this. I'm going to show you an example where it's the opposite in a minute. Now on the other side, these outputs are getting very tiny in almost the same proportion, are getting very small. So when you guys, when they're talking about like the coronavirus being an exponential growth, this is what they mean. This is when you look at those graphs and you see it like sharply like increase when they've been showing on the news or in the paper, the number of cases, that's because the growth is just that explosive. It models exponential formulas. Okay. This is actually more relevant than I would care for it to be in our life right now. Any questions? All right. So let's look at one like this. Let's look at when the base is a fraction. Okay. So now the base is less than 1. Let's just see how this behaves. So I'm going to let you guys calculate it. I'm going to put in 0. We want 1, 2, and 3. And then I want -1, -2, and -3. So go ahead and see if you can figure out those calculations on your own. Give you a couple minutes. Oh. Oh. Okay, for the negatives, did you guys get it's 1/1/2, like to the -1, which is just 2? This is 1/1/4, which is just going to be 4 because it'll be 1 times 4/1. This is 1/1/8, which is 8. Is that okay? Are you guys with me on that?
Yeah.
Okay. Any questions? These other ones are a little more straightforward. You just got to square them. So it's 1/2, 1/4, 1/8. All right, so here we go. Any questions on how to get those numbers? All right, well, here we go. So let's graph this. All right, so 0, 1, 1, 1/2, 2, 1/4, 1/8, and then -1 goes up to 2, -2 goes up to 4, -3 goes up to 8. So what's happening here?
The opposite.
Exponentially
Negative is going
decreasing.
up, positive is going down.
Yeah, it's what's opposite? Trying to.
The negative side is increasing, and then the positive side is decreasing.
Yeah, very good. Imagine as if we took this first graph and we just swung it around the axis. Like imagine if you just like hit it and it swings around. That's what this graph is, isn't it? Okay. It's the same inputs, outputs, but in the flipped direction. So this is called, it reflects around the y-axis. Okay. But now my outputs are bigger here. And then outputs are small here. Oops. So this is f of x is equal to 1/2 x. Now, I want to point out that this x-axis here, see how this line rises along the x-axis? It's never going to cross it. It will just get smaller and smaller and smaller. Okay, so again, imagine f of, in this problem, we'll do like f of 20. That's going to be 1/2. I'm sorry. Yeah, 1/2 to the 20th is actually going to be 1/2 to the 20th. Okay, that is a huge number on the bottom, but when I divide it, it's actually going to be very, very small. Is everybody okay with that? So the x-axis has a special name, but it's not anything new. What is it called? What do we call those things when the graph rides alongside it but never crosses it?
Asymptotes.
Yeah, it's an asymptote. So the x-axis in this case is the first time we really like talk about this in a meaningful way. It's a horizontal asymptote. The graph rides just above it, but never crosses. Okay. Next semester, you're going to talk a lot more about horizontal asymptotes, but for now, I just want you to have seen it before and understand they exist. Okay. They are slightly different than vertical ones. There are some horizontal asymptotes that you can cross, but vertical ones you never cross. Okay. We're not going to get into all that detail. Any questions on that? All right. 9.3. So this was kind of like 9.1, 9.2's introduction, but we're going to get into log functions because that's where a lot of this stuff is at. We got to know lots about logs. All right, so here's a definition. Log base a of x is the exponent. It's the exponent of a to get x. All right, so here's some notation issues. All right, a is the base function. We call it the base function. Base of the function, sorry, base of the function. And we have a new domain restriction. Aren't you happy? I mean, we were already getting so tired of just the regular two, which are what? What's the first domain restriction we always have to be aware of?
N equals 0.
What can't equal 0?
The denominator.
Beautiful. Yes, the denominator cannot equal 0. That's one of our domain restrictions. Anybody remember the second domain restriction we know?
An even square root can't be negative.
Beautiful. Can't put negative numbers in even square roots. We now have a new third restriction, which is that the input in the log function cannot be negative or 0. So this right here, okay, the input must be positive. Never negative, never zero. Okay. That's exciting. You're like, why are you laughing? Okay. Because math is fun. All right, let's do some examples. The log stuff, I find students generally do pretty well with this. So find each of the following. It's usually not too bad. So here's number 1. Look at log base 3 of 9. Oh, I know there's something else I wanted to tell you, but I'll tell you after we're done with this. All right, so find each of the following. So what I'm asking is, the question is, what exponent that goes on 3 will give me 9? Okay, that's basically what it's saying. What is the exponent we will put on the base to get 9? So I see in the chat, people are like 2. Yes, makes sense. 3 squared is 9. Okay, so it's the exponent you would put on the base to get that number inside the parentheses. That's what we set up here. It's the exponent on A that will give you X. Okay, all right. How about this one? Log base 3 of 27. 3. Okay, the question is what goes on 3 to give you 27? It's 3. Okay, any questions on that? Okay, so if you want, you can write because 3 to the 3rd is 27. Okay. All right, let's try this one. Log base 5 of 1/5.
-1.
-1. Why? Because 5 to the -1, that power gives us 1/5. It's the exponent that will go on your base. Any questions there? All right, what about this? Log base 6 of 1/36.
-2.
Good, Michael. 6 to the -2 will give me 1/36. So the power is -2. The answer is the exponent, the exponent, the exponent. Okay. All right, how about this one? Log base of 1/10 will give me 100.
Would it be -2?
Yeah, it's also -2. I just flipped it on you. So 1/10 the what power will give me 100. Well, I know we have to square it. 1/10 squared is 1/100, right? How do I flip that? Make it negative. Okay, so this is -2. So the negative just means you're going to flip it, right? Ooh la la. Okay, how about this one? Log base 10 of 0.01. Ooh, okay, let's look at this. 10 to what power is going to give me 0.01? Now, you either need to write everything in decimals or write everything in fractions. And I think at this point, with this, it's a little bit easier to see if you write 0.01 as a fraction. What is that as a fraction? 1 over what?
100.
100. Tenths, hundredths, okay? How would I go from 10 to 1/100th?
It would just be 1 over 2 or negative 2.
Yeah, it's going to be 10 to the negative 2 because that's 1 over 10 squared, which is 1 over 100. So that's my exponent. So here's another one where the exponent is negative 2 and it still looks kind of different. Okay, so be really careful. You can't just, you got to think these through sometimes. You can't just like guess. You have to think, okay, what power can I put on 10 that will give me this? Let's do one more like this. Log base 10 of 0.1. How do I go from 10 to 0.1?
Negative 1.
Yeah, negative 1. That's 1/10 with the 0.1. So this one's negative 1. Any questions? All right, what about this one? Log base 7 of square root of 7. What
1/2.
exponent? What is it?
1/2.
1/2. 7 to the 1/2 is square root of 7, right? So the exponent that goes on 7 that will give me what's inside that parentheses is 1/2. Good. What about this? Log base square root of 11 will give me 11.
Squared.
You square it. Okay. So square root of 11, how do I get 11? I have to square it. So the exponent that goes on square root of 11 that will give me 11 is 2. Any questions? All right, last one. It's the most challenging one. Log base 9 of 27. Now, if I look at 9, 9 to the power of 1 is 9, and 9 squared is 81. So it's can't be one of those.
Would it
I'm
be-
looking for what I can do to 9 that's going to give me 27.
Would it be 2/3
That's what I was.
or 3 over 2?
All right, let's try that. Which one do you want to try, 2/3 or 3 over 2?
I think it's 2/3.
I think it'd have to be the 3 over 2 because you'd have to square root the 9.
Okay. Yeah, so look at the difference of what these two things say. If I say 2/3, it's a cube root of 9 squared. Well, 9 doesn't cube root well. I don't know what the cube root of 9 is squared. But this one says the square root of 9 cubed, which is, what's the square root of 9? 3. What's 3 cubed? 27. So the exponent on 9 would be this 3/2. That is correct. All right, one more like this. And then I want to leave you with a couple other things. Final thoughts. Log base, let me be careful here. Log base 16 of 64. Mhm. What can I do to 16? That's going to give me 64.
Wouldn't it be the same thing again?
It
Right.
is actually, yeah. It is the same thing. So if I take the square root of 16 and cube it, that's 4 cubed, which is 64. So it's 16 to the 3 halves. Okay. Just to see that kind of twice. All right. So last couple things. Just some notation. The thing you should notice here is that the log, I don't know, log base a of x, whatever exponent that is, okay, it's the same thing as saying your base a to that power equals x. So that these are the same statements. And you can see in just what we've written. So log base 3 of 9 is 2, just like 3 squared is 9, okay? So these are equivalent statements. They mean the same thing, essentially, okay? And then the other thing I want you to know is that any log to the base 10, any log of x, if you don't see a base written, this is understood to be, so fact, understood to be base 10, to be in base 10. So this is equal to the same as log base 10 of x. If you don't see a number written there, it is automatically base 10. All right. I will post everything on Canvas with a new updated to-do list. Are there any questions? Office hours today at 5, tomorrow at 11:30. I will see you otherwise tomorrow morning, 10:30. All right. Have a good day. Bye. Let me stop recording.